Hello guys, so here we have a question on network theory based on RLC network. So the following series RLC circuit with zero initial conditions is excited by a unit impulse function delta of t. For t greater than 0, the output voltage Vc of t is dash. So this is the circuit they have given, and options, if you see, here it is like a over damped response, this is like a critically damped response, and these are like under damped responses, right? So let us find out what is the voltage Vc of t. So this one is easier to approach in the frequency domain than in the time domain, because in time domain for the initial conditions for with delta of t input it's difficult. So we can go to the Laplace domain and solve it in the Laplace domain and convert it back to the time domain. Okay, so in Laplace domain this is equal to 1, right? And this will be s into L, which is nothing but s itself, and this is 1 ohm, and this will be 1 by s. So what is the transfer function? Vc of s by Vn of s is nothing but it is 1 by s by s plus 1 plus 1 by s. So if we have to simplify this, we got 1 by s square plus s plus 1. So V in of s is gonna be equal to 1. So your Vc of s is 1 by s square plus s plus 1. So now we have the transfer function of Vc of s, or we have the frequency domain response of Vc of s. So now what we have to do is we have to check for the poles, because to convert it back into the time domain we either want it in the 1 by s plus a into s plus b form, yes, because that will be giving us a exponential response in time domain. So if it is sine or cosine, what will be the function? So if it is e power, or in the time domain if it is e power minus at sine bt into u of t, then in the frequency domain it is actually b by s plus a square plus b square. Similarly for cos e power minus at cos bt u of t, it is nothing but s plus a divided by s plus a whole square plus b square. So we want to try to bring it to this form to be able to convert this into time domain. So first let us see what the poles are. If it is both the real poles, then we'll get something of this form. If the poles are imaginary, then we should try to do it in this form. So here let us take b square minus 4ac, the determinant of this. So b square is 1 square minus 4 into 1 into 1. So this is equal to minus 3. So this is less than 0, which means that the poles are going to be imaginary. So already in the options two things we can eliminate, right? It is neither critically damped or over damped. So it is the under damped response. So we need to find whether this is cos or sine. Okay. So let us go back here. And here what do we have? So now we need to convert into something like this form. So Vc of s is equal to 1 by s square plus 2 into s into 1 by 2 will give me s, right? So plus 1 by 2 whole square. We already have 1 here, and I'm adding and subtracting 1 by 2 whole square. Okay. So then what we have? We have s plus half whole square plus 1 minus 1 by 4, which is 3 by 4. So this is how you need to convert it into a s plus a whole square plus b square form. Okay. So now if you see from this only, you can guess what it's going to be, what form it's going to be. If you see in the numerator, there is no s term. If you see here for sine, there is no s term in the numerator. It is just a constant. But for cosine, there is a s term. So it is going to be sine only. So from here only, you can say the option is D. But still, let us try to solve it fully. Okay. So what do you have? You have 1 by s plus 1 by 2 whole square plus root 3 by 2 whole square. For it to be in this form, I need to multiply and divide by b, because here b is missing. So I'll multiply by root 3 by 2, divide by root 3 by 2. So I'll have 2 by root 3 into root 3 by 2 divided by s plus 1 by 2 whole square plus root 3 by 2 whole square. So if you convert it into time domain, Vc of t, what will it be? 2 by root 3 will be there. And what is my a here? It is half. So e power minus 1 by 2t. So if you go back to the formula you have here, right? So s plus a is e power minus at, and this b is nothing but your frequency of your sine. So you have sine of root 3 by 2 into t. So this is what we already guessed also. So our option is option D.